This is section 10.3 on polar coordinates. So polar coordinates are r and theta, r comma theta, and Cartesian coordinates are x comma y. And you can go back and forth using these four formulas. To go from r and theta to x and y, you would use the top two. And to go from Cartesian to polar, you would use the bottom two. All right, so the first example wants us to convert this polar coordinate into Cartesian coordinate. So that means we're going to use the top two. So r is 4 and theta is 4/3 pi. So let's plug in those values. For x, we're going to have 4 cosine 4/3 pi. And for y, we're going to have 4 sine 4/3 pi. And evaluating this gives us 4 times -1/2, which is -2. And evaluating this gives us 4 times negative radical 3/2, which is -2 radical 3. So our final answer would be -2, comma, -2 radical 3. That is the final answer. All right, for the next example, there are two parts. They want us to first find the polar coordinates, r theta, when r is positive and theta is between 0 and 2 pi. And for the second part, the same thing, only they want the r to be negative and theta is still between 0 and 2 pi. So this is x comma y this time. This is Cartesian coordinates. And the other thing you want to make sure is that you know which quadrant the coordinate is in. This is positive negative, which means that would be quadrant 4. So it's a good idea to write that down so you know which quadrant your angle should be in. Okay, so now we're going to use the other two sets of formulas, which is r squared equals x squared plus y squared, which means that r squared is equal to 3 plus 1. R squared is 4. R is positive 2 or negative 2, depending on which part we're doing. We're doing part A, so we want positive 2 for the first for the first part. For theta, we're going to do tangent of theta is equal to y over x. And this is the part where this comes in to play. We're in quadrant 4, so you're looking for the angle that's in quadrant 4 that has this tangent value. And it turns out to be angle 11/6 pi. All right, so for the first part, part A, our answer is going to be positive 2, comma, 11/6 pi. For part B, now we're on part B, they want the negative angle, the negative r, so that would be -2. All right, and for the angle, since with polar coordinates, if you have a negative r, that means you're going to go the opposite direction. So if you're going 11/6 pi and you go in -2, then that means you would actually be going this direction, which would put you in quadrant 2. So that's not the correct angle that we're going to use. We want to be in quadrant 4 ultimately. So that means we have to go to this angle, 5/6 pi, and -2 would go in the opposite direction, which would put us in the correct quadrant, quadrant 4. So this is the angle we're looking for, 5/6 pi. Oops, wrong color. All right, that is the final answer. So once again, angle 5/6 pi is this way, but since it's -2, that means you're going to go in the opposite direction, which would put you right there, which is where you need it to be. So that is the final answer. All right, let's move on to the next part, part B. Same directions. This is x comma y. So we're doing the same thing that we just did earlier. R squared is going to be x squared plus y squared, which is 36, which means r is plus minus 6. For this one, because the angle is actually on the x-axis, you don't even need to use the formulas. You already know that your point is over here at -6, 0. That's your point. So this is pi. So the angle is pi. So for this, you would just have to write your r is positive 6, your angle is pi. And for part B, they want the negative angle, which would be negative 6. So in order for it to be negative 6, you'd have to go angle 0, and then negative 6 would take you in the opposite direction. So for this part, you want angle to be 0 radians. All right, that does it for that part. Let's move on to the next problem. They want us to identify the curve by finding a Cartesian equation. So this equation's in polar coordinates. We need it to be in Cartesian, meaning x and y. So what we can do here is we can use the formula. Let's see. Well, first let's rewrite this as r equals to 4 over cosine, which we're allowed to do by definition. Multiply both sides by cos, and you will get, you're going to get r cosine theta equals to 4, and this is equal to x. X is equal to 4, and that's our equation. It's a vertical line at x equals 4. Same thing for this next example. So here we're going to replace y with r sine theta. And x, we're going to replace it with r cosine theta. So squaring this, we're going to get 4r squared sine squared theta equals r cosine theta. All right, we can rewrite this as subtract over this term over to the left side, and you'll get 4r squared sine squared theta minus r cosine theta equals 0. We can factor out an r. 4r sine squared theta minus cosine theta. All right, so we either have r equals 0, or we have 4r sine squared theta minus cosine theta equals 0. And if you solve for r, you're going to get r is equal to, you're going to bring the cosine over and divide by 4r. You should get 1/4. What is that? That's going to be a cotangent. And then you're going to get a cosecant theta. So, and when theta is pi over 2, this is going to be 0, and this is going to be 1. So this entire thing will be 0. So this will be included in this equation. So ultimately, you don't really need the other equation because this equation includes this one already. But they're both solutions. So this is your final answer here. All right, let's look at the next example. So this one says, sketch the curve with the given polar equation by first sketching the graph of r as a function of theta in Cartesian coordinates. So to graph this in Cartesian coordinates, you would draw xy axis. But instead of x, it's theta and r. But you can treat this as a x and treat this as a y. Cosine looks like this. That would be one period of cosine. But since it's a negative cosine, that means it's going to go in the opposite direction, like that. And then this is a vertical translation. So it's going to raise everything 1 unit up. So your final graph will look like this. That's 0, that's pi, and that's 2 pi. That's one complete revolution. So I just did transformations. The original graph of cosine looks like this. But because it's negative, that means it's reflected over the x-axis, so it looks like that. And then this is shifted up 1 unit, so everything went up 1 unit. All right, so that's what it would look like. That's the Cartesian graph. And now we're going to do the polar. So polar, This is going to require a little bit more work. So what I would recommend is that you do an R theta table. And I'm going to choose some values. I'm going to choose 0, just convenient values, pi over 4, pi over 2, 3/4. Actually, 3/2, sorry. I'm going to go pi. And, oh, actually, I didn't mean to do 3/4, sorry about that. 3/4. That would be pi, then 5/4, then 3/2, then 7/4, and then 2 pi. So I'm going through all the angles on the unit circle. So now if you plug this into the equation, if you plug that into to theta, sorry, I got these backwards. This is theta. This is r. All right, so if I plug this into theta, I'm going to get the following values. I'm going to get 0, get 1 minus radical 2 over 2, which is approximately, on my calculator, 0.29. This is going to give me 1. This is going to be 1 plus radical 2 over 2, which is approximately 1.71. This is going to be 2. 1 plus rad 2 over 2, which is approximately 1.71. This is 1. 1 minus rad 2 over 2, approximately 0.29. And this is 0. All right, so now let's draw the graph using polar coordinates. Okay, so I'm just going to do a little bit of tick marks here. Okay, so this is radius 1, radius 2. All right, this would be angle 0, angle pi over 2 pi, 3/2 pi, comma 2 pi. All right, so now we can just plot these points. These are ordered pairs, r, comma, theta. So 0, 0 would be our first point. That's right at the origin. And then we got, for angle pi over 4, that would be right here, 45 degrees. That's 0.29. So that would be approximately right here, if we're just to guesstimate something. Yeah, just guesstimate. And then at angle pi over 2, that would be up here. That would be 1. So that'd be about right there. So actually, this would be a little bit closer to the origin. And then for the next angle is 3/4. That would be 1.71. That would be somewhere out here. And then for 2, for pi, it's going to be 2. And then for 5/4, it's going to be 1.71 again. And then for 3/2, it's going to be 1. And then for 7/4 pi, it's going to be 0.29. And then back to 0. So it's going to look like this. And the direction is this direction. It goes that direction. All right, so it's not a perfect graph, but you get the idea. All right, so that's what we're going to do for the next example as well. So this would be polar. All right, so this would be the last example. Okay, so for this one, let's start with the Cartesian graph again. So sine generally looks like this. That's one period. But since it's negative, that means it's going to start and go down first. And the period is going to be different. So from 0 to 2 pi, you're going to be able to fit 5 periods because of that coefficient in front of theta. So it's going to look something like this. Go down. There's 1, 2, 3, 4, 5. So that's 5 complete periods from 0 to 2 pi. So once again, it's 1, 2, 3, 4, 5, and that's because of the 5. So that would be your Cartesian graph, or the graph in Cartesian coordinates. And now we got to do the one in polar coordinates. And once again, we're going to do that r theta table again. All right, so my angles, this time I'm going to select strategically my angles to be angles so that I'm getting 0, pi over 2, pi, 3/2 pi. So I'm getting angles at each axis. So if I do that, I'm just going to save you guys the time and trouble to think about it. It's 0, pi over 10. If you plug in pi over 10, you're going to get pi over 2. And then I'm just going to increase by 1/10 pi each time. So 2/10 pi, 3/10 pi, 4/10 pi, 5/10 pi, so on and so on until I get to 2 pi. So that means I got to go all the way to 20. It's a little tedious, as you can see. So I'm going to continue over here on this side. There will be a pattern you will see. Okay, and so if you plug in all these angles into this equation, you're going to get the following values. 0, -1, 0, 1. And then you're going to get a repeat. It's just going to cycle again. It's just going to go over the same values all over again. So it just keeps on doing that. So 0, -1, 0, little 1, and then it just repeats again. 0, -1, 0, 1, 0, -1, 0, 1, and then 0. All right, so now let's draw the graph in polar coordinates. All right, so wherever you see a 0, 0, r, there's going to be an asymptote there. So at 2/10, we can actually draw an asymptote there. So it'd be approximately here. And then there'll be another one at 4/10, which would be around here somewhere. And then there'll be another one at 6/10, which is going to be on this side. And then there'll be another one at 8/10, which would be over here on this side. And that's pretty much it. All right, so if you go to this angle, 1/10 pi, that would be about right. That's going to be about right here, right in the middle. And so this angle, it's got a value of -1. So instead of going that way, you're going to go the opposite direction. So it's going to be here. So it'll be about right here, length 1. And then you would, at 3/10, it's going to go to +1. So 3/10 is going to be 1/10, 2/10, 3/10 is here. So it's +1, so it's going to go actually there. And then at 5/10, 5/10 would be right here, 5/10. It's going to be at -1, which means down here. So that would be about right here. And then at 7/10, that's going to be right here. It's going to go +1, so it'll be right there. And then the next one would be 9/10. So 9/10 is going to be about right here. It's going to go to -1, which means it's going to go in this direction, so right here. All right, and then 11/10, that's going to be, 11/10 would be right here, and it's already there. As you can see, 11/10 already has one. So that's basically it. It's just going to be these little petals go in and out. All right, and that is it for this section.